Today on the Tech Bytes podcast, we're talking about how your organization can adopt a hyperscale model in your network to do things like improve TCO, scale out capabilities and services, and get supply chain diversity. Our sponsor is DriveNets, and we're speaking with Run Almog. He is head of product strategy. Run, welcome to the podcast. And so why do I want a hyperscale approach if I'm not, say, an AWS or a Facebook?
Well, to start with, you want to be as big or as strong as the hyperscalers. But there's one thing to look at is that the hyperscalers built something really big. They started small and they made all sorts of arrangements onto the ecosystem in order to enable them to do that. Essentially, They built whatever their infrastructure was, they built it like cloud. And this is exactly where service providers need to look at in order to grow and be as strong as and as capable as the hyperscalers.
Okay, so my immediate question to that is, what is it that makes a network cloud in your mind? How does DriveNets put together a networking architecture that takes on the valuable business features? Because that's cloud is a business thing. It's not really a technology thing, right? Except insofar as it's software. But how does DriveNets do that?
Right. So cloud is kind of a consumption model. Another word to describe a cloud is something which is consumed as a service. In order to do that, you need to look at your resources as a pool of resources. When you mount an application onto the cloud, you consume resources. There's a mechanism that allocates and protects these resources for that application. That does not exist in networking. And this is exactly what DriveNets has done in the sense of grabbing all the infrastructure, all of the resources which exists within the boxes that we are using and allocating them according to the right application. The right application.
So pitch me, how do you do that, right? Because that sounds good to me, but does that mean I'm actually getting a white box switch and installing your operating system on top, and then I've got this software operated infrastructure which now lets me configure it, so I can create VRFs and MPLS and microsegments? Is that the limits of? Is this the general idea?
That's the general idea, and much more. Because when you take a single box, eventually you end up with a single box. When you take a cluster of boxes, then first off, you can bring these boxes from multiple sources. And secondly, you have a pool of resource which you can enlarge while the network is still alive. While your infrastructure is already running, you can enlarge it and scale it out. The logic of this, being the fact that you can not only run a single instance or a single application, or I should say a single router onto that infrastructure, but you can also group in multiple functions into that same infrastructure. So if I have,
this is kind of like a chassis, and each line card in the chassis does some forwarding and some smart. So it presents the Ethernet ports forward, and each blade in a chassis has the forwarding engine, and sometimes it has the smarts in it. And then if it needs to route the packet off into the next card, it just routes over a backbone to it. So conceptually, DriveNets is building a chassis-like architecture out of 1RU, 2RU Broadcom silicon.
Yes, and the differences are chassis is a great thing, but it has limitations. The one classic trivial limitation is the actual metal enclosure that wraps up this chassis. So we don't have this enclosure, which means that we can scale indefinitely and just add more and more boxes. The second thing is that all of these boxes are standard interfaces based. So you don't have anything proprietary that prevents you from taking in additional equipment and making it interoperate with what you already have. Everything is standard, everything is generic, and by the fact that it's all white boxes means that the source where these boxes should come from is also something that you can control.
Yeah, you just raised an important point, because I'm thinking, okay, you're trying to sell me some kind of special FPGA or SmartNIC or something, or dedicated hardware that I'm tied to. You're saying this is running on merchant Broadcom silicon on a white box that I could get from any number of vendors.
Not only that, but the box is also open in its architecture, and it's contributed to the OCP.
Okay, great. So then the secret sauce then happens in your software layer?
Precisely. Our software layer creates an abstraction of all of these hardware resources and eventually allocates these via API onto whatever application that the network operating system needs to run. Like I said at the beginning, we started with routing, and then you can expand these functions onto additional network functions such as firewall, DDoS prevention mechanism, DPI, all sorts of other network functions, traditional network functions.
Okay, so I'm getting a package of the tradition. When you say application, you're actually talking about a networking function.
Exactly, but not only. When you look at other applications that have some sort of a benefit of running as close as possible to the network, then it doesn't necessarily need to be a network function per se. It can also be an application such as, I don't know, a gaming host that needs to be as close as possible to the subscribers. So putting it inside the network means a lot in terms of latency and the user experience.
Okay. So do I need to buy different types of boxes for different functions like a core routing, aggregation routing?
Well, essentially, it's two boxes. Like you said at the beginning, there is a fabric box and there is a line card type of box. All of these boxes have a CPU, they have an NPU inside, and then the allocation of these hardware resources onto APIs or consumable resources for the function is something that the operating system is taking care of.
Got it. Okay, you mentioned APIs. What kind of software chops would I, as an operator, need to have to get this box up and running and make it work and do things I want it to?
Well, as an operator, you will start with a working function, right? You will have a router and you will operate that router traditionally, just like you use any other router, and it will interoperate with all of whatever routing mechanisms that you have in your network. That's a given, that's working. When you take it to the next level of introducing your own innovation onto your network and create differentiation between yourself as a service provider and other service provider, this is when you will face our already kind of ongoingly defined API. To start with, we're working with some service providers from the direction of them defining what they want to achieve, and then we build the API underneath it accordingly. At some point, once it's going to be a little bit more robust, we will open this API and make it kind of open for the market in general.
Now, one of the things that DriveNets does is you actually take this idea of this clustered hardware and unifying it into a single forwarding plane, and you're actually able to turn this into a router or a multi-router, as you described it to me. Do you want to explain? So is that sort of like I can take 10 modern network switches, 100 gig network switches, and turn the whole thing into a big router with, say, 10 slots of chassis-like performance? Is that the fundamental principle?
Well, it's yes and no. I wouldn't say that you can take just any white box from the market. It needs to be boxes that were built for that, for the purpose. And yes, once that's established and you take whatever boxes according to the, say, OCP definitions, then you can mix and match different vendors, different types of boxes, different ASICs within it. The software will kind of be able to consume all of this and treat the cluster, that close topology of boxes connected to one another, and make all of this behave and appear to peering devices as a single entity.
Well, you've always got to, at the end of the day, the ASICs that are inside the switches matter, and the CPUs that are on those boards that drive those ASICs matter for software operations. That's no different to a server, right? If you can't just run any software on any server, you always have to be at least somewhat concerned about the horsepower that's underneath. But the principle is kind of there. You're able to turn the network into a shared resource, but you're also able to turn many small switches into one big routing engine.
Exactly. Eventually, all of these standalone boxes appear, behave, communicate to peering devices as one unified entity. It's one network element in terms of IP addressing, routing tables, and so on. It's one device.
And I'm not locked into a particular supply chain thing, which is important today. If you've got urgent requirements about getting stuff done, that ability to have diverse supply is going to be relevant to a lot of people.
It's a matter of control. As a service provider, you want to have maximum control over whatever you enter into your network. When you're buying from one vendor, one type or two types or five types of different equipment, eventually the vendor has every control over what you insert, when you insert things into your network, when you innovate, and how much time before you actually need to deploy a new service or a new box do you need to place the order. Sometimes it's a year in advance. When you have multiple sources and even multiple or different devices coming in, and they all serve the same purpose under one software package, then in terms of control, the operator now has control. If it doesn't get whatever he's looking for from vendor A, he will get it from vendor B, and essentially it will operate exactly the same.
And that's where the cloud aspect of this comes in that the underlying hardware, as long as it meets some basic requirements, it doesn't matter what it is. Just like in a cloud, my compute infrastructure doesn't matter if it's Dell or HPE or some white box, as long as I've got that orchestration and overlay on top where I'm getting all the value from. You're doing the same thing just with routing.
Precisely that. It's exactly like you said. It's Dell and HP or other brand names, or you can go into ODMs and just take any server which doesn't even have a recognized name, and it costs a lot less, and it does exactly the same.
Now, maybe you've got a use case where cutting corners is the right thing and getting away from a brand is the right solution, but you need the same unified operation. So I've got the same operation for this high-end service that I'm providing, but sometimes I need to get a cheap box and I want to use the same tooling, the same operations, the same help desk processes to achieve that.
Exactly. The type of box that you're entering can be a lower cost or a higher cost, higher capacity or lower capacity. It's up to you in terms of the hardware feeds and speeds, in terms of how this box operates and being operated and orchestrated as part of your network. It's the same look and feel.
I think the other cloud aspect of this is that when I need to increase my capacity, be it CPU, throughput, whatever, I just add another box to the cluster, right?
That's the whole purpose of being able to scale out. If you could add infinite cards into a chassis, you would. And that's what you have here. Building this into a class topology essentially enables us to add more and more line cards, so to speak. And each such line card has, like you said, a CPU and an NPU. These are two blocks, hardware blocks within the box. They are consumed as resources. The more boxes that you had, that pool of resources increases. So if you want to add a function onto an existing platform and you're missing, TCAM entries, then you will add a couple of more boxes and increase your TCAM size. And then you're able to introduce that new function.
And your hardware, your software is performing that abstraction function to make sure I'm just building a pool as opposed to having to do other kind of tweaking to get it into my cluster.
Yes, I would say that's the key thing that our software is doing. That's the most interesting and sophisticated thing.
Now, we talked a little bit about applications or services I can run on top. Can I do security functions in addition to networking functions? Like if I need a firewall service?
Post routing as the first thing that we did, security was the second. It's the classic approach of introducing security onto your network. That was a classic, yeah.
Right, okay.
Now, and like we said, this isn't necessarily that you're going to go and buy a brand name firewall and drop this onto the, in a container on these switches, but this is the direction that you're heading.
Yes and no. Yeah, Yes, you would be able to buy a top line, state-of-the-art, branded named firewall and mount it onto an existing infrastructure. What needs to happen before is for us to work with that firewall provider in order to make the proper adjustments so that the firewall will work as a cloud
so it'll see the interfaces.
Like
it'll see the router interfaces or the physical interfaces, and it will work appropriately and all that type of stuff. So it's not
and enable itself to be distributed, because that's the idea. The application needs to be distributed over the multiple boxes. Otherwise, the scale out doesn't work.
All right. Now, you've got customers doing this today. I just want to touch on this very quickly because you're not fresh out of startup mode. You've actually got carriers and telcos and tier 2 cloud providers running this today.
Correct. Starting with AT&T, and this is running the core of AT&T, that this technology, very large clusters, actually the biggest that we built, are running this core for AT&T. And in addition to that, we have a couple of other carriers in the US. We have customers in Asia Pacific, in Europe, all tier ones, by the way, and they're all doing great things, not only core routing, but also peering, aggregation routing, PE functions. All of this is in production.
Well, Run, before we finish up, are there any thoughts you want to leave us with?
Yeah, this is what we call multi-service, and perhaps it's worth another emphasis. Having one routing functions running on a cluster is one thing. Having multitude of these is another thing. And when you have your points of presence, a central office, and you have a PE router there and a core router and an aggregation router, they are all co-located onto the same facility. And Network Cloud enables to run all of these different routers onto that same infrastructure. So it's one cluster and it's running all network functions. This is what we call multi-service.
Okay, so one cluster, multi-service. That's a good way to think of it.
Exactly.
All right, well, folks, if you've piqued people's curiosity, they want to get more information, where should they go?
Our website, www.drivenets.com, as simple as that.
Fantastic. All right, that's drivenets.com. Well, thank you, Run, for joining us, and thanks to DriveNets for being a sponsor, and thank you for being a listener. If you like this episode, you can find it and many more fine free technical podcasts along with our community blog. It's all at packetpushers.net. You can follow us on Twitter at packetpushers and find us on LinkedIn and rate us on Apple Podcasts. Last but not least, remember that too much networking would never be enough.